Okay, let's look at trigonometric ratios. Now, actually, this aspect of maths compare the size of right angle triangle, okay? And we'll be working with the acronym SOHCAHTOA. Actually, the first one, SO, stands for sine theta is equal to opposite over hypotenuse, that is for SO. Then for CA stands for cos theta is equal to adjacent all over hypotenuse, and TOA stands for tan theta is equal to opposite over adjacent. And we have another one, we have cosec. Cosec is actually the inverse of sine theta. Now, since sine theta is opposite all over hypotenuse, then cosec will now become hypotenuse all over opposite, because cosec is inverse of sine theta. We have another one, sec theta. Now, sec theta is the inverse of cos theta. Now, since cos theta is equal to adjacent all over hypotenuse, then sec theta will now become hypotenuse all over adjacent. We have another one, cot theta. Then this cot theta is inverse of tan theta. Now, since tan theta is opposite all over adjacent, therefore cot theta will now become adjacent all over opposite, okay? Now, we actually use this SOHCAHTOA to look for one side of a right angle triangle or a particular angle in a right angle triangle when sides are given. If we are to find one side of a right angle triangle, then one of the sides of the right angle triangle will be given to us and a particular angle. Or if we are looking for an angle in that right angle triangle, then at least two sides of the right angle triangle will be given to us for us to use and find the angle, okay? Now, we have example here. In this example, we have a right angle triangle of sides 12 cm, x cm, and we don't have anything here. Then we have an angle 58 degree, and we are to find the value of x, okay? Now, for us to find the value of x, we'll first of all define these sides, okay? Now, how do you define this side? We'll start with the side that is opposite to the 90 degree here. So this side is hypotenuse, okay? So this side is hypotenuse. So that means that hypotenuse is 12 cm. Then we now come back to this angle. In this angle now, the line that is opposite to this angle is this one. And the one that formed this very angle with this hypotenuse, the side that formed this very angle with this hypotenuse is this side, and it's adjacent. So adjacent is not given. But this side that did not contribute in the formation of this angle is the part we are looking for. And this part is, this side is opposite now, okay? So we have opposite, we have hypotenuse, and also we have angle 58. So we are to write it out first here. We have theta, we have hypotenuse, and we have opposite. So we will now go to this SOHCAHTOA to look for the one that have these three things that we have here. It is this one. So this is the x here stands for sine theta. We have theta, and the O is for the opposite, and opposite is x that we are looking for, and the hedge is now hypotenuse. Okay, that means this is the one we are going to work with, the SO. Okay, and this SO means sine theta is equal to opposite all over hypotenuse. Now, the next thing we are going to do is now to substitute all these values in this place. Now, instead of writing sine theta now, we will now write sine 58 is equal to, instead of writing opposite, we will now write x, because x is our opposite. Now, instead of writing hypotenuse, we will now write 12, okay? Now, we will now cross multiply because we are looking for the value of x. So x times 1 is x. Now sine 58 times 12 will give you 12 times sine 58. Now we now find the value of sine 58, which is 0.8480. So if we multiply the two of them, it will give us 10.176, approximately 10 cm to the nearest cm. Okay, thank you. Okay, let's take example number 2. The example, we have find the value of alpha from the diagram below. So in this diagram, we have to look for the value of this alpha. Okay, now the very first thing we'll do is to define these sides. Now starting from here, this is our 90 degree. So this line is a hypotenuse. Okay, now this alpha is actually formed by the combination of this hypotenuse and this very line here. So because of that, this is our adjacent. This side is our adjacent. Okay, now this other line that did not participate in the formation of this alpha will now become the opposite. Okay, so we have, from what we have here, we have opposite to be 9.13. We have adjacent to be 11.9, and we have hypotenuse to be 15. Okay, now since all the sides are given and we are looking for alpha, it means we can use either so or ka or toa. Okay, now if we want to use so, what do we do? So, which is sine theta, so we stand for sine theta is equal to opposite all over hypotenuse. Okay, so if we want to use so, we now ask ourselves which of these parameters can we use. Now we have opposite to be 9.13. So look at our sign. We now begin to substitute what we have here. So instead of writing sine theta, we now write sine alpha, because what we are given is alpha. Then it's equal to, instead of writing opposite, we now write 9.13, because our opposite is 9.13. Then all over, instead of writing hypotenuse, we now write 15. Okay, sine alpha will now give us 9.13 divided by 15. So if you divide this, it will give you 0.6086. Okay, so sine alpha is now 0.6086. Now, since we are looking for alpha, not sine alpha, we have to look for sine inverse of this number. Sine inverse of 0.6086. Okay, now how to press that in our calculator is you press shift, then sine 0.6086. Okay, so it will give you 37.4883 approximately. Okay, so we have 37.4883. So we can now approximate it to 1 decimal places. So alpha is equal to 37.5 degree to 1 decimal place. Okay, now if we don't want to use sine to solve, we can use cos. So we now have cos. So cos alpha will give us adjacent all over hypotenuse. Remember that cos theta is equal to adjacent all over hypotenuse. So cos alpha will now be adjacent all over hypotenuse. So in this place, our adjacent is 11.9 and our hypotenuse is 15. Okay, so we can now substitute those values in this place. Now instead of writing cos cos theta is equal to adjacent, we now write cos theta is equal to 11.9 all over for hypotenuse, we now write 15, okay? So if we divide this, it will give us 0.7933. So like the same thing we did, since we're looking for alpha, we'll now look for cos inverse of 0.7933. It will now give us 37.505, then approximately 37.5 to 1 decimal place, which is the same thing we got here, okay? Now, if we don't want to use sine or cos to find, we can equally use tan theta to find it. Remember that tan alpha is equal to opposite all over adjacent, okay? Now, our opposite is 9.13 and our adjacent is 11.9, okay? So if we substitute those things here, instead of writing opposite and adjacent here, we now write 9.13 all over 11.9. So by the time we divide it, we will get 0.7672, okay? So we now do tan inverse of 0.7672. It will now give us 37.4954, okay? Approximately 37.5, okay? Okay, we have another example here, okay? So we have a right angle triangle here, and we have a side here, YCM, and 13.67, and another side here without value, and we are looking for the value of y. So the question is find the value of y, okay? So the first thing we will do is to define all these sides, okay? Now starting from our right angle triangle, our 90 degree, we will trace this way. So this is our hypotenuse, okay? Now this line that form this angle 65 degree with hypotenuse is now our adjacent, okay? And this other line will now become the opposite, okay? So adjacent is that very line that form the included angle with the hypotenuse, okay? So this line that form this angle with this hypotenuse is the adjacent. So this is hypotenuse and this is opposite, okay? Now, since we are looking for y and y is adjacent, that means that we have an adjacent. That is why I wrote here y is an adjacent and 13.67 is the hypotenuse, 65 is the angle. So we are going to look for the acronym that has adjacent, hypotenuse, and theta from SOHCAHTOA. And the one that has adjacent, hypotenuse, and theta from SOHCAHTOA is CAH, okay? CAH, C-A-H. So which means cos theta is equal to adjacent all over hypotenuse, okay? So the next thing we will now do is to replace all these things with the value we have here. So our theta is 65, so we'll now write cos 65 is equal to, our adjacent is y, so we'll now write y all over, our hypotenuse is 13.67, okay? So for us to find y, we will now cross multiply. So y times 1 is y, cos 65 times 13.67 is what we have here. Now the value of cos 65 is 0.4226. So by the time you multiply these two, you will have 5.7769, approximately 5.8 cm. So our y is approximately 5.8 cm to 1 decimal place, okay? Okay, we have another example here. So the question is find the values of theta, x, cosec theta, cot theta, and tan theta, okay? So the first thing we will do is to know our sides, okay? So from what we have here, this is our hypotenuse. We have hypotenuse here, and this is our adjacent, and this is now the opposite, okay? So x is opposite, 6.1 is adjacent, 8.5 is the hypotenuse, okay? So from there, we say that we have an angle theta is there. So hypotenuse, which is 8.5 cm, and we have also adjacent, which is 6.1 cm. Now the next thing is to look for the acronym that has angle, hypotenuse, and what? Adjacent. And the acronym is CAR, which is cos theta is equal to adjacent all over hypotenuse, okay? So now because we are looking for theta, we'll just replace all these things with the value we have, so that our cos theta will now become 6.1 all over 8.5. So by the time you divide this, you will have 0.7176. Now because we are looking for theta and not cos theta, we'll now find the cos inverse of theta. Cos inverse of theta. Okay? Now, for us to press the cos inverse, since we have the cos theta to be 0.7176, so to get the cos inverse, we just press shift cos, then the value 0.77, no, not 77, 0.7176, okay? So it's equal to 44.1331417, okay? So we'll take 44.1433, okay? Now approximately 44.1 to 1 decimal place. So that is our theta, okay? Now the second question says we should find the value of x, and our x is now the opposite. So that means that we need the acronym that has opposite, also the one that has either adjacent or hypotenuse, and then angle theta, okay? So we have angle theta to be 44.1, and we have our opposite, which is x, and also we want to use hypotenuse, which is 8.5. So since we have theta, opposite, and hypotenuse, the acronym that has these three things is sin theta, okay, which is SOH. So sin theta is equal to opposite all over hypotenuse, okay? Now remember that our theta is now 44.1, so we now write sin 44.1 is equal to our opposite is now x, then all over 8.5, which is our hypotenuse, okay? Now since we are looking for the value of x, we just cross multiply so that our x is equal to sin 44.1 times 8.5. So the value of sin 44.1 is 0.6959, then times 8.5. When you multiply these two numbers, it will give you 5.91515, approximately 5.9 to 1 decimal place, okay? Okay, the next one is cosec theta, that's number C. Now, cosec theta is inverse of sin theta. That means cosec theta is equal to 1 all over sin theta. Now, since sin theta is equal to opposite all over hypotenuse, and cosec theta is inverse of sin theta, that means that cosec theta will now become hypotenuse all over opposite, okay? And from our diagram here, our hypotenuse is 8.5 and we have found our opposite to be 5.9. Okay, so that means that here hypotenuse is 8.5 all over 5.9, which is our opposite. Okay, so if you now divide this, you will have 1.4407. that is our cosec theta. Okay, they say we should find cosec theta, so that is our final answer there. Now the next one is cot theta. Okay, now cot theta is inverse of tan theta, and since tan theta is opposite over adjacent, therefore cot theta will now become adjacent all over opposites. Okay, and our adjacent is 6.1 and our opposite is what we got here, 5.9. so we can now replace it here. So from this formula we have here, so we now have 6.1 all over 5.9. okay, so by the time you divide this, you will have 1.0339. that is our cot theta. Okay, now the next we have is tan theta. Tan theta is opposite all over adjacent, and our opposite is 5.9. then our adjacent is 6.1. so by the time you divide this, you will get 0.9672. okay, thank you.